So in this video, we are going to be talking about linear inequalities. So linear inequalities are basically the exact same as a linear equation, except we don't have the equal sign, we have the inequality sign. So we still have y's and x's, but instead of an equal sign, we just get the less than or greater than or equal to signs. For a solution of a linear inequality, it's going to be a lot different than your normal solution for an equation, because a solution for an equation is any ordered pair that would fall on the equation's line. So anything that x and y you put into the equation which makes a true statement. For a linear inequality, we actually have things that are off the line or may not even be on the line itself as an ordered pair that makes this true. So we actually are going to be doing some shading, and anytime you are trying to solve for a linear inequality, you're going to want to graph it. So unlike with linear equations where we had three options of graphing or substitution or elimination, with linear inequalities we want to actually graph it so we can actually see where our solutions lie. So we have two new pieces that we are going to add to graphing a line, because everything we do here is going to be the exact same as what we've been doing when we graph a line. We still find the y-intercept, we still find the slope. Now there's just going to be two things that are going to be different. One of the two things is the weight of the line. So what I mean by the weight of the line, I mean that is the line going to be a solid line like you see here. So this is a solid line, so what you're used to. Or is it going to be a dashed line like you see here? So here we have a dashed line. So the difference between the two is going to come from our inequality sign. So if we have the or equal to piece, then it's going to be a solid line. So the way to think about this is the equal to piece is creating that solid line. And that's what you're used to seeing when you draw a line. You draw a straight line that is solid, and that's because everything on that line is equal to. So that's part of the solution. Now, if we have a less than or greater than without that or equal to piece, it's going to be dashed. So that's very important. It's basically saying nothing on that line is actually a solution. So it's almost like it's an imaginary line and we're creating this boundary there. So nothing on the line is actually a solution, whereas the or equal to piece, those are all solutions. So that's the first thing that's different. The second thing that's different, you probably notice that there's shading on this graph. So the shading is the area of your solution. So anything in any xy point, any point in that shading is a true statement for your linear inequality. So therefore it is a solution. So if you have a y is greater than or a y is greater than or equal to, you are going to be shading above the line. So that, or greater than, so you're thinking something is above you. If something thinks, or if someone thinks they're greater, they think that they're above you. So the other one is if you have a less than or equal to sign, then you're going to be shading below. So if you think that something's less than, it should be below. So that's where we're going to get our shading to come in. So that is the second thing that is different than when you normally graph a line. So the first thing, should I make it a solid line or should I make it a dashed line? The next thing, should I shade above the line or should I shade below the line? So that is basically how you need to think about these problems. First, you're going to solve for y, where it's in slope-intercept form, so you can sketch your line, but you need to think, should I make it solid or should I make it dashed? Then, should I shade above or should I shade below? So those are the steps you're going to do. So you're going to go through like it's a normal line, except Do I need to shade or make it solid or dashed? Shade above, shade below. So that's your train of thought. So let's look at an example here. So we want to graph the solutions for this linear inequality. So I want to start by solving for y. So that means I want to isolate y. So I'm going to start by subtracting 4x on both sides and also subtracting 2 on both sides because I want to get my y by itself. So on the left side, the 4x minus 4x is going to cancel, the positive 2 and the negative 2 are going to cancel, leaving me with a negative y. And I still have the less than or equal to sign, and 0 plus these two things is just negative 4x minus 2. So the last thing I need to do is I need to get rid of this negative sign. So what I'm going to do is I'm going to multiply both sides by a negative 1. You can also divide by a negative 1. It's the exact same operation. I'm just trying to get rid of this negative, and a negative times a negative makes it a positive. So on this left side, that's just going to cancel. And on the right side, notice that I put my whole right side in parentheses. That's reminding me that I need to distribute this negative 1. So the other thing is I multiplied by a negative. So since I multiplied by a negative, I need to go and flip this sign. So I'm going to flip the sign. So this is now a greater than or equal to negative 1 times negative 4x gives me 4x. Negative 1 times negative 2 gives me a positive 2. So now this is in slope-intercept form. So I want to look at my symbol that I have. So this is the greater than or equal to. So this is going to tell me the two things I need. Since we have the or equal to piece, this is going to be solid. So because we have this or equal to, it's going to be solid. And because that it is greater than, we are going to be shading above the line. So we know that we're making it solid and we want to shade above the line. So let's go and sketch out what this looks like. So my y-intercept is positive 2. So I'm going to come here to positive 2 and I'm going to put a dot. My slope is 4 over 1. So my slope is 4 over 1. This is telling me to go up 4 and this is telling me to go right 1 since they are both positive. So going up 4, 1, 2, 3, 4, right 1, there's my dot. So I'm going to flip the signs of both of them so I can go the opposite direction. So negative 4 over negative 1, because again, two negatives make a positive, so this doesn't change it, just the way it looks. So this is telling me to go down 4 and left 1. So from my point, my y-intercept, I'm going to go down 4 and left 1. So at this point, I want to make sure that I am thinking about whether or not it's solid or dashed because we're used to always drawing a solid line. So before you draw that line, just recheck, should I make it solid? And in this case, since we had that or equal to piece, yes. So I'm going to come over here and I'm just going to draw a solid line, remembering to put my arrows. And then we just need to shade. So we said that it is above the line, so I'm going to come above the line and I'm going to shade. So everywhere above the line I am shading. So don't think about left or right, think about up and down because we're talking about y is greater than. Y is up and down, so I'm going up from every single one of these points. So if I put my point here, so this is just a random location, and I went straight up, that's telling me that I am shading above that line. So that's why you see that the blue is in that area. So again, if I had picked a random point and I went straight up, because we're talking about above, then I'm making sure I'm shading in that area. So the last thing, typically they want you to just pick a random point and to say that that is one of these solutions. It may ask you for multiple solutions. So just pick a point. So one of the nice things about the or equal to, you can always pick a point on the line, or you just pick a point anywhere in the shade. So I'm just going to pick this random point, and that random point is -2, 1. I'm just going to pick another one for fun. I'm going to pick this one right here. So that is 0, looks to be 5. So those are each solutions, and if I plug them into the equation, it's going to become a true statement. So if I plug in 0, 5, I will see that whatever it is less than 0. If I plug in -2, 1, again, I'm going to see whatever that left side simplified down to is less than 0. So I have one for you to try. So again, start by graphing or solving for y, graph it, figure out if it's solid or dashed, above or below, and then come back and check. So this is what yours should have looked like, and you could pick a random point. 0, 0 would have worked perfect here. 5, 5 would have been great, so forth and so on, as long as it's in the blue shade but not on the line. Since this is a dashed line, we cannot say any point on that line is true.